Morning to one and all. Today I am starting the lecture number 4 in the shaft couplings. I am Dr. Y.C. Taramara, Associate Professor, Department of Mechanical Engineering, Gayatri Vijaya Parishad College of Engineering, Visakhapatnam. Today we will discuss about what do you mean by the coupling and what are the requirements of the coupling and what are the advantages of the couplings and the classification of the couplings and what are the how do you design the couplings also that we will discuss in this class here. We should see the picture of the couplings here in the slide. Coupling and clutch are the power transmission elements here. And both are used for transmitting power from one shaft to the other. What are the different types of couplings in the figure that you should observe? The rigid coupling, how it is similar to be here. And here the driving shaft and driven shaft both are joined here, the means of the bolts. And the sleeve coupling here you see that the total mass is divided into two parts here, that is called the sleeve coupling. Flange coupling here, which are joined by means of the flanges. These are the flanges which are connected by means of the bolts. And the clamp coupling here, both the two sleeves here are two halves of the sleeves are connected by means of the clamping the bolts here, that is the clamp coupling. And bush coupling here is the one of the example for the bush coupling, which will absorb the shocks and vibrations. And the universal type, universal coupling here to connect the shafts which are intersecting at some angle. And gear coupling, Woodham coupling, jaw coupling, bellow coupling, diaphragm type, and fluid coupling here. These are the various types of the couplings here. Now, so these couplings are, which it can be used for transmitting power from one end to the other by means of the shafts. If suppose the distance between the two shafts or two ends is very large, say 8 to 10 meters you can take, it is not possible to transport by means of joining these two shafts here. So it is necessary to join two or more pieces of the shaft by using the couplings here. Now, what are the requirements of the good shaft coupling here? The shaft coupling is in a position to easy to connect and disconnect. What do you mean by that here? Very easy, means you should not have a complexity in connecting the shafts or disconnecting the shafts here. It's very easy so that the coupling must satisfy the requirement here. And we should be in a position to provide perfect alignment of the shafts. Means shafts do not have any kind of misalignment. Both are in one axis of the shafts. That is the perfect alignment. Generally, the shaft coupling should be able to connect the two shafts. If they are making some kind of offset, then it is not possible to connect the two shafts in a good manner here, to connect it here. And to avoid the transmission of the shaft load between the shafts, so whatever the coupling you are selecting, you should be in a position to avoid the shock loads between the shafts. Sometimes the sudden loads are acting on the shafts, some bending load or axial load or the shear load or combined loads are acting on the shafts. In that case, we are in a position to avoid the transmission of the shaft loads here between the two shafts, and should transmit the full power between the shafts without any kind of losses. That is also one of the important requirements. And what are the advantages of the coupling here? Couplings are having a lot of advantages here. To alter means to change the vibration characteristics of rotating units, means compressor or turbine. The frequency or the speed of the compressor you want to change it. Then you have to add the coupling by means of connecting the pulleys to the belts or the chains here. Rotating units, you have to connect it here. Compressor and a pump or the turbine, you have to connect it so that these are in the position to change the vibration characteristics the way we require depending upon the type of application we need. To connect the driving and driven parts and to introduce the protection against overloads is also able to protect the overloads also, and to provide misalignment of the shafts And to introduce mechanical flexibility means that is the coupling should be able to connect the shafts and the turbine and the pump and the compressor. So we have some kind of flexibility to connect with the shaft components here and to reduce the shaft loads from one shaft to another. And these are also to avoid the slip when overload is occurring. That also one of the advantages of the coupling. We have to take care while you are selecting the coupling here. And basically, the shaft couplings are divided into the two types here. One is the rigid coupling and another one is the flange coupling here. So in the rigid coupling, these are rigid to connect the two shafts which are perfectly aligned. The shafts are in the same axis. Along the same axis, the shafts are mounted here. That way the alignment is taking place here. In that rigid coupling, we have the further subclassification as the sleeve or muff coupling, clamp or the split muff or the compression coupling, and flange coupling. And again, the flange coupling, it is again classified as the unprotected type flange coupling. Means this is the bolts and nuts which are connected to the coupling are open. Means there is no enclosure for covering the bolts and the nuts of the flanges here. And another one is the protected type flange coupling, which it will be protect the operator close, and it acts as a enclosure of all the bolts are keeping here, so that it is safe for the operator. That is the protected type flange coupling and marine type flange coupling here. And the second classification is the flexible coupling. These are used to connect the shafts having both lateral and angular misalignment here. These we are classifying as the Bushnell type coupling, Oldham coupling, and universal coupling. There are three types of couplings here in the flexible coupling. And applications where we are using this kind of couplings here. These are used to transmit the more power as compared to the flexible couplings of the same size, and these are used for the application where the machines are operating at the higher temperatures, say a compressor or the turbine or the pump here. So in order to connect the shafts, the propeller shafts in the jet engines for connecting, we are using the couplings here. And in the automobiles, we are using here. And trucks to connect the two shafts, we are using. And the smaller size couplings are used for the height or capacity and the stiffness. These are the applications of the coupling, and it contains not having any kind of backlash between the machine elements. And flexible couplings we are using in the mainly in the steel industries we are using, and the petrochemical industries we are using, off-road vehicles and heavy machinery we are using. And they are also used in the office machines, servo mechanisms, and the instrumentation and the machinery also. We are using the flexible coupling because of the flexibility of the operation. We are using the flexible couplings. And the next one is the sleeve or muff coupling. Here in this coupling, what is happening? You see the figure here. The ends of the two shafts are connected by means of the muff, which is enclosed over the two shafts here, which is connected by means of a jib-headed key as shown in the figure here. Initially, the power is transmitted from the driving shaft to the driven shaft through the muff and the key. And again, the power is transmitted from a muff to the driven shaft through the key, a jib-headed key. So in this figure, you see here the muff and the key. This is the key and the shaft, the shaft diameter, and the length of the muff, and the outside diameter of the hub here. So this is about the here in the jib-headed Sankey also provided to hold the sleeve and the shaft together. Thus this forms a rigid coupling. That is the working principle of sleeve or the muff coupling. The second one is the split muff coupling. So in this split muff coupling, muff is split up into the two semi-cylindrical halves, which are held together by means of the spirited bolts and nuts. Just you see in the figure itself here. This here. It is split into the two halves. This is half and this one is another half. You see in the figure side view of the figure also. These are connected by means of a feather key, which is as shown in the figure here. You see here. So the main advantage of this coupling is that it could be connected at anywhere in the machinery itself here. That is the advantage. At any part of the machine we can connect it very easily. That is the main advantage of this spectrum of coupling. And the next one is the flange coupling here. It consists of the two similar cast iron flanges at which the shafts are keyed with the help of the taper keys. And the machine flanges are also very tightly held together by exact fitting of the bolts in the holes. You see here how the flanges are exactly machined in such a way that it fits into the holes of the bolts. Here you see here how it is fitting here. These are machined so accurately in such a manner to fit into the drilled holes of the bolts here. Okay, very accurately we can do the fixing of the flanges here. Machining is important. And unprotected type, as the name indicates, you see here, the flanges are open. And the couplings which are connected to the bolt, this is open. It is not protected by any kind of enclosure or the cover. That's what is known as the unprotected type flange coupling. You see the part, the shaft, of the flange and key. Here also the power is transmitted from the shaft to the flange to the key, driving flange, and from driving flange to the driven flange to the hub and the shaft here. Okay, in this way the power is transmitted from the driving shaft to the driven shaft here. These are the outer dimensions of the flange. Capital D equal to 2D, outside diameter of the hub, and pitch circle diameter of the bolts is given by D1 is equal to 3D, and the outer diameter of the flanges are given by dt equal to 4D. Length of the muffle equal to 1.5 here. These are the dimensions. And protected type flange coupling, each flange is provided with some kind of projection for covering the bolt heads and nuts here. This is to prevent the catching the flows of the workman and ensure the safety. You should observe the figure here. Some kind of enclosure or protection of the coverage taking place in the protected type flange coupling here. This is more important. That's the difference we can identify easily for the unprotected and protected type flange coupling. And the last one is the bushwood pin type flex coupled coupling here. These are used where the slight relative motion is required between the two shafts here. The axis of the shafts are run slightly out of the line here. And the pin type couplings are mainly used. These are known as the pin type couplings are used here. These are the bushes. You see how the bushes are connecting here. Brass bush we are using, the rubber bush also we are using. These bushes are absorbing the shock loads in the coupling. That's the advantage of the flexible coupling here. And the motion from one half of the coupling to the other half is imparted with the help of the driving pins which are rigidly bolted to one plane. You should observe here how these are rigidly fixed to the plane here, and loosely fitting corresponding holes in the other. And brass bush and rubber covering is also provided on the driving pins for absorbing shocks and insulators, and it does not transmit any kind of shocks from one shaft to the other. This is about the bush pin flexible coupling. Okay, thank you very much for patiently listening to this part. Thank you.